Everyone, and welcome to Tutor Time. My name is Chrissy.
And I'm Ashley.
And in tonight's episode, we're going to be covering material from MAC 20 through 11, and we'll be doing a practice exam from last semester for your exam coming up next Thursday. We want to remind you that Tutor Time is brought to you by the Teaching Center located in Broward Hall, where we offer you guys a variety of services that are all free to you. All you need is your Gator 1 or just your Gator 1 ID number. And those include private appointments, walk-in hours, supplemental group tutoring, as well as Tutor Time, which you are watching now. So to find out more information on that, you can visit our website at teachingcenter.ufl.edu, where you can find a schedule of all the different hours that we offer walk-in hours. You can sign up for private appointments, or you can even look at our schedule of Tutor Time and download our podcast. So definitely check that out. And it's not just for math. We do the lower and higher level math, but we also do a lot of science, like chemistry. We do business classes like economics, finance, statistics, like digital logic. Pretty much anything you need, you can request something. We'll try and find someone that is available to tutor you or help you in that subject. So also, we want to remind you that you can email us or call us in throughout the show, and our email is uf-tutor@ufl.edu, and our phone number is 352-392-6420. So we'd love to hear from you guys. Just call us in with any questions you have, even if it's not on the exam we're covering. If it's related to Calc 1, we can help you with it. And if you email us, remember we only cover the emails that are sent up to this show. So if you have a question, you can go ahead and email us throughout the week at any point, but it's probably just easier if you come in and see us if you want it answered right away.
Or call us when we're on air.
Right. All right, so Ashley's going to start with question 1, and this is
exam 2 from the fall, and it is
2A.
version A, yeah. But in this exam, if we don't get through it, this exam, or if you just want to work through it yourself, is available starting today, I believe, in the math lab. We wanted to go ahead and do it on air so that you guys could see if you had any questions or if you were going to go watch this later via a podcast. You know, in preparation for your tests, you had something to look at. So the first question says to find f prime of x. And when it gives us that f of x is equal to x cube root of 3x minus 2. All right, so we're going to be taking the derivative, obviously, and we are going to have, we're going to be using not only the product rule, but also the chain rule. So you guys are going to definitely have to know all of your different differentiation rules. I'm going to erase this right now. I'm going to go ahead and rewrite this. Instead of having this cube root here, I'm going to make it an exponent. So I'm going to rewrite our cube root as a power to the 1/3. So we're going to have x times 3x minus 2 to the 1/3 power. So that looks a little easier for me to work with. And now I'm going to start by taking my derivative. So I'm going to do my product rule. And so I do a derivative of the first, which is just going to be 1, times my second, 3x minus 2, quantity to the 1/3, plus the derivative of my second. And so for the derivative of this, I'm going to have 1/3 times the front, which is just 1/3, times 3x minus 2, so that the power times the front coefficient, and then you have the inside, to the 1/3 or 1/3 minus 1, and then you multiply by the inside, the derivative of the inside, which will just be 3 for us. So this first portion is just the derivative of my second, and I can't forget to multiply by my first term, which is just going to give me x. And so looking at this, I can simplify off the bat this 3 and the 1/3. And this will leave me with 3x minus 2 quantity to the 1/3 plus x times, and remember 1 is just, in terms of thirds, it's 3/3. So that's going to give me a 3x minus 2 to the negative 2/3. And then I can even, if I wanted, simplify it some more by taking out this, factoring out my 3x minus 2. I'm going to factor it out to the power of the negative 2/3. Yeah, because if you get to this point and you look on your answers, none of them are in this format. So you know maybe you have to take it to the next step. So we're going to factor out 3x minus 2 to the negative 2/3. That leaves me inside. When I take out a negative 2/3, that means I'm going to add that back to this power. So that gives me 3x minus 2 to the 3/3, which is just 1. So it's just going to be 3x minus 2. Plus, I have x times and then 1. So I can just actually have just x. But I take out to the negative 2/3, remember, because I'm factoring out my common term with the lowest power. So, yeah. So now I can, again, rewrite this some more. I can bring this down as a denominator. I can move it to the bottom. And that will be the cube root of 3x minus 2 quantity squared. And then here I have 3x plus 1x, so that leaves me with 4x minus 2. And that answer is B. Right, and so they leave it to the 2/3, and I just put it as a cube root, but that's the same thing. So yeah, so Chrissy is going to do problem number 2.
Can you use that marker?
Yeah, actually they got new markers, and they're all awesome.
Oh, sweet.
They give out a lot of ink, which also makes the board really gross.
Okay, so looking at number 2, we need to find the derivative, and then we need to find the derivative at pi 6. So we have f of x is equal to tangent squared of 2x. Okay, and then we want to find f prime of pi 6. So in order to do this, it's always a good idea to figure out what rule you're going to be using before you move on throughout the problem. So we know we have tangent of 2x, but this is going to be a chain rule problem because now we have our, for instance, our first function is tangent of 2x. And then our outside function is x squared. So what we're going to do here is we're going to work with the outside function first. So I'm going to bring down my exponent, and I'm going to be left with tangent of 2x. And now the exponent is 2 minus 1, which is just 1. But now of my inside function, my tan 2x, I need to take the derivative of that as well. So this is going to be times secant squared of 2x. However, I still have another function inside of here. So I need to take the chain rule one more time for this 2x, and the derivative of 2x is just 2. So simplifying a little bit, I'm going to get 4 tangent 2x times secant squared of 2x. And now I want to, so this is my f prime of x. I want to evaluate my derivative at pi 6, so plugging in for x equals pi 6, I get 4 tangent of 2 times pi 6 times secant squared of 2 times pi 6. And so this just becomes 2 times pi 6 is really just going to become pi thirds. So I'll simplify that here. And 2 times pi 6 is also pi thirds. Now we know that the tangent of pi thirds is going to be the square root of 3. And secant squared of pi thirds, so we know that secant of pi thirds is equal to 2. And so 2 squared is going to be 4. So now I'm left with 16 square root 3. And that is answer choice
E.
E. Okay.
All right. Moving on to problem number 3. All right. Problem number 3 wants us to it says the total cost in dollars of producing X units of a new product is given by the function C of X is equal to 0.2x cubed minus 0.4x squared plus 40x plus 1200. And it says we want to find and interpret the marginal cost when x is equal to 10. So marginal cost, you have to remember, is going to be the derivative of your cost function. So you're going to want to take the derivative and then substitute in x. Whatever they give you for x. So our derivative, our c prime of x, is equal to 0.6x squared, because we take 3 times 0.2 and then subtract 1 from 3, minus 0.8x plus 40. And that was just using the basic power rule. And now we're going to find c prime of 10. That's going to equal 0.6 times 10 squared minus 0.8 times 10 plus 40. And that is equal to 10 squared, we know, is 100. 100 times 0.6 is 60. 0.8 times 10 is 8. And we've got our plus 40, so it's going to be 100 minus 8, which is 92. And this, again, because this is in cost, this is in dollars. And it is, our answer choice is answer choice C. It says the cost is increasing by $92 per unit at 10 units. So it means if we were to find out what it would cost us to make one more unit after 10 units, well, that's $92, which is kind of expensive, but maybe you're making something really expensive anyways. So, and it's increasing from at $92 because $92 is positive. If it had been negative, that would have been, our cost would have been decreasing by that amount. So yeah, that is problem number 3. Ready?
Okay, so for number 4, we want to evaluate the limits. And they give us, as x approaches 0, of sine of 6x all over 4x times cosine of 3x. So we know that we can't use direct substitution for this one because when we plug in 0, we're going to get 0 over 0, which is an indeterminate form. And I don't believe you guys have gotten to L'Hopital's rule yet. So we're actually going to evaluate this using squeeze theorem and just some good old-fashioned trigonometry tricks. So remember that the sine of 6x, or the sine of any angle, I'll write 2 times alpha, is going to be, our double angle formula is 2 sine of alpha cosine of alpha. So here if we let alpha be 3x, now we have that the sine of 6x is equal to 2 sine of 3x cosine 3x. And the reason I did that is because I saw I had a cosine in the denominator. So if I can get one of those to cancel out, that will be helpful. So I have limit as x approaches 0 of, now the top becomes 2 sine of x, sine of 3x, cosine of 3x, all over 4x cosine 3x. So we see that these can simplify out, and we're left with, this becomes sine of 3x all over 2x. And I still have my limit as x approaches 0. So we see something familiar that you should have done in your notes or homework, and we know that the limit as x approaches 0 of sine of, I'm just going to write alpha over alpha, is going to be 1. And I believe you guys did that with the squeeze theorem. So we have something similar, but here my alpha is 3x, and here my alpha is 2x, and I need the bottom to be 3x. So I'm going to multiply by 3 halves, because that'll cancel out the 2, and I'll be left with a 3x. But remember, whatever I do to the bottom, I must do to the top because we can only multiply by 1 here. That's the only thing we're allowed to multiply by. So we get the limit as x approaches 0 of 3/2 sine of 3x all over 3x. And we know that now this part here, so we have limit as x approaches 0, and I can pull out that 3/2 because it's just a constant. And the limit as sine approaches 3x over 3x is just going to be equal to 1. So now I have 3/2 times 1, which is just 3/2. And that is going to be answer choice A. All right.
Lovely, lovely. Thanks.
Oh, God, my hands are dirty.
I know. All right, so we shall be moving on to number 5. Are you guys excited about your test yet?
Woo!
Already through number 5. If we can do it this fast, you can do it this fast, right? All right, so number 5 says that if f of x is equal to inverse sine of 2x, then what is f double prime of x? So not only are we taking the derivative once, we're taking it twice. Right. So you have to remember something here, and that is the derivative of inverse sine. And that is a formula. So if we have inverse sine of a, hold on, I just need to write down. Yeah. Inverse sine of a, that formula, the derivative, according to a, I guess, would be equal to 1 over the square root of 1 minus a squared times whatever the derivative of a was, dA. So, for us here, because, you know, we are taking the inverse sine of something more than just one variable x, we're going to have this dA that we're going to have to deal with. So, and remember, this is only for the first derivative. We're going to have to take the derivative again once we get a value. So inverse sine is going to be 1 over the square root of 1 minus our 2x quantity squared times the derivative of 2x, which is just 2. So that gives me 2 over the square root of 1 minus 4x squared. I'm even going to erase the square root, and I'm going to put to the 1/2 power, because remember, those are the same thing. And so I can even write this again, because I personally prefer doing product rule to quotient rule, but it's whatever you feel comfortable with. You can do this either way. I'm going to show you using product rule, but you can, as equally the same, do quotient rule. So I'm going to rewrite my derivative as 2 times 1 minus 4x squared to the negative 1/2, just by bringing that quantity up with a negative exponent. So now I can take my second derivative, and that's using the product rule. So I want the derivative of the first, which is 0, times the second, plus the derivative of the second, which is going to be, remember, we're going to have our negative 1/2 times 1 minus 4x squared, and negative 1/2 minus 1 will give me a negative 3/2 times the derivative of the inside, which is going to be negative 8x. And that's my derivative for my second term times my first. So again, I can simplify this. I'm going to have positives because both of those are negative. You can cancel out this 2, make this a 4. So now what I'm left with is, I've got 4x times 2, which will give me 8x, over 1 minus 4x squared to the 3/2. All I did was bring this 3/2 down to the bottom because it had a negative exponent. And that is answer C. Yeah, C. 8x times over 1 minus 4x squared to the 3/2. All right.
Okay, number 6. I can do that other one. I don't know.
What?
The log one.
Okay.
Sorry. Okay, for number 6, it says find each value of x at which the tangent line to, so our function is x squared plus 2 all over x, is perpendicular to the line 3y minus x equals 5. So first of all, keyword perpendicular. When anything is perpendicular, we know that the slope is going to be the negative reciprocal. So solving this, I get x plus 5, and this is y equals 1/3 x plus 5. So my slope is 1/3. So that means if I'm looking for a line that's perpendicular to that, then my slope is going to be -3.
Can I see that?
Yeah, 1 second. Yeah, go ahead. So what I want to do is now I want to take the derivative of my function because I was looking for, sorry, what was the question?
Tangent line.
Find each value at which the tangent line is perpendicular to this line. Okay. So my derivative is going to be, if I want to use, there's a variety of ways you could do this. You could simplify this first, or we can just use the quotient rule, which I'll do since you guys should be practicing that anyway. So we're going to take the bottom times the derivative of the top, and the derivative of the top is just 2x plus, minus the derivative of the bottom, which is just 1 times the top, all over the bottom squared. And that is equal to 2x squared minus x squared minus 2 all over x squared, which is just x squared minus 2 over x squared. And I want to find all values of x for which I believe it was perpendicular to those tangent lines. So that means all those values are going to have a slope of -3. So now I just need to solve this. So I'm going to get -3x squared equals x squared minus 2. And this becomes x squared equal to 1/2. So we know that when we take the square root, that x is equal to 1 over the square root 2 or -1 over the square root of 2. And that is, sorry,
It's okay.
answer choice D. So that's number 6.
All right.
Oh, sorry.
No. Okay. All right. So now we are working in our trig functions again. And it says find each x value on the interval from 0 to 2 pi. At which f of x is equal to cotangent x plus 1 over cosecant x. And to where this function has a horizontal tangent line. So remember, horizontal tangent lines are where our derivative is equal to 0. So we want f prime of x equal to 0. And so I'm going to need to take the derivative of this. You're going to need to have all those memorized again. So we're going to probably use the quotient rule for this. And the quotient rule goes the derivative of the high, which is derivative of cotangent x is cosecant, negative cosecant squared x. And then derivative of 1 is 0, negative cosecant squared x times the low, which is just cosecant x, minus the derivative of the low, which is negative cosecant x cotangent x. times the high, which is cotangent x plus 1, all over low squared, and low being cosecant x, and we're just going to square it. So here I'm going to change those both to positive. Yeah. And so I've got a negative cosecant cubed x plus cosecant x cotangent squared x plus cosecant x cotangent x all over cosecant squared x. And out of each of these, I can simplify by eliminating a cosecant x. So I get rid of this one here, one out of there, and one out of here. So now I'm finally left with negative cosecant squared x plus cotangent x, or cotangent squared x, sorry, plus cotangent x all over cosecant x. So now I need to, for this to be, for them to have horizontal tangents, our slope is going to equal 0. So we're going to need to set the top portion equal to 0. Yeah, this is awesome. Okay, so we've got negative cosecant squared x plus cotangent x plus cotangent squared x, right? Yes. And I'm going to have to factor that somehow.
Use a
Pythagorean theorem, yeah. Because I obviously want all of these in the same terms, so I'm going to want cosecant is equal, well, right, so cosecant we know to be 1 over sine. So if we divided everything through by sine squared, we get that 1 plus cotangent squared is equal to cosecant squared. Right. So
1 minus cosecant squared.
Right.
Is equal to
Cotangent squared. Right, but we are just going to change cosecant. So we're going to put 1, and this is negative. We have 1 plus cotangent squared x plus cotangent x plus cotangent squared x. Sorry, this is like that. So then we've got negative 1 minus cotangent squared.
And that cancels.
Plus cotangent x plus cotangent squared x. So our cotangent squares will cancel, so that's good. And so now we just have cotangent x minus 1 is equal to 0. And now you set cotangent x equal to 1, and we know that cotangent is cosine over sine. I'm going to have to erase some of this because I need some room.
It's the same place where tangent is.
Right. So we have cotangent x is equal to 1, and we know that this is cosine over sine is equal to 1. And so cotangent is equal to 1 wherever tangent is equal to 1. And so that's where sine and cosine have the same value, but also the same sign. And so that happens at pi over 4 and 5 pi over 4. So x is equal to pi over 4, 5 pi over 4. And that is the E, right? Yes. And that is letter E. So it's a little confusing, and you have to add in a lot of things. So once you get down here, then you have to change cosecant into a version of cotangent using your Pythagorean theorem. All right.
Okay, so next we're going to do number 8. And that says to find the slope of the tangent line to 2xy is equal to sine of y plus 1 at the point -1, comma, -1. Have they done implicit yet? Okay, all right, cool. So this is going to be This might not be on their exam because the tests are different dates.
I think they do implicit.
Okay.
Yeah.
Well, this one is going to be an implicit differentiation problem, so you might be doing that coming up in your class if you haven't already done it yet. But this is how we would go about doing that, and we want to look for the slope of the tangent line. So remember, slope of the tangent line is just taking the derivative, but only this time we're going to do it implicitly. So now we have the product rule here. We have 2xy. So the derivative of the first, so the derivative of 2x is just 2 times the second function plus the first function times the derivative of the second. And we know the derivative of y, if it was with respect to y, is just 1. But now we also have to multiply that by y prime since we're doing this implicitly. Here we have the cosine of y plus 1, and the derivative of the inside is just going to be y prime because the derivative of y is just 1 times y prime, and the derivative of a constant function is just 0. So now we can plug in for x is equal to -1 and y is equal to -1, and then we want to solve for our y prime. So 2 times a -1 plus 2 times a -1 y prime cosine of -1 plus 1 times y prime. So here I get a -2 minus 2y prime should be equal to, and then we know that the cosine of 0 is just 1, and so this whole thing just becomes y prime. And so I'm going to move the y prime over to the other side, and the 2, add 2 to both sides, and I'm going to get -3y prime. And so my answer, when I divide by a -3, should give me y prime is equal to -2/3. And that is answer choice A. So just be very careful that you don't forget these extra y primes in here. It's easy to forget them, but if you do, you would have gotten a different answer. In particular, I believe you would have gotten, well, something else. Anyways, it wouldn't have been right. So that's how we do that problem.
So that was number 8. Now we're doing number 9. And number 9 asks us to find the equation of the normal line to f of x is equal to e to the 2x minus 3 quantity squared at x equals 0. So normal line, what is that? Well, normal line means that we have some curve, like that, say, and we've got the tangent line, right, at some point here. Our normal line is perpendicular to that tangent line. So that means our tangent line has a certain slope that we find with taking the derivative, and then our normal line is going to be the negative reciprocal of that slope. So, knowing all of that information in your head, we're going to first plug in our x and just see what value we get at f of 0, because if we're going to be writing a line, we need a full point, not just the x value. So if I plug in and find f of 0, I get e to the 2 times 0 minus 3 quantity squared. E to the 0 is just 1 minus 3 gives me -2. To square that is 4. So my point is 0, 4, and I'll need that later. So I need to find the derivative of this. So I'm going to use a chain rule. And my derivative here, it's 2 times my inside. So 2 minus 1 is 1, times the derivative of my inside. The derivative of my inside is just going to be e to the 2x, that stays the same, times the derivative of this function, 2x, which is just 2. So my f prime of x is going to be 4e to the 2x times e to the 2x minus 3. Now this value at f of 0, or at, sorry, x equals 0, so we're taking f prime of 0, gives me 4e to the 2 times 0 times e to the 2 times 0 minus 3. And that, we know e to the 2 times 0 is 1. So that gives us 4 times 1 minus 3, which is negative 2, which is equal to negative 8. So if we want the normal line to this slope, it's going to be the negative reciprocal. So our slope of our normal line, I'm going to m sub n, is going to be equal to positive 1/8. Because it's the reciprocal, so it's flipped and it's negated, but it's already a negative 8, so a negated negative is just a positive. So now we have our slope, and we have our 0.04, so we can just put it into point slope form, and we have y minus 4 is equal to 1/8 times x minus 0. And so that gives me that y is equal to 1/8 x plus 4, and that is answer B. So yeah. So just, you have to remember little things, and you know, the normal, it being a normal line is just mentioned quite briefly. I don't know how much your teacher goes over it in class, but it's mentioned very briefly in the book. So even sometimes the little things you're tested on. So you want to be very thorough in your studying. All right.
Thanks.
Oh, sorry, yeah.
Thanks. Okay. Number 10 says to use logarithmic differentiation to find f prime of 1 if f of x is equal to e to the x plus 1 square root x all over x squared plus 1. So they even tell you to use logarithmic differentiation. So instead of f of x, I'm just going to write y is equal to this. So we know for a logarithmic differentiation, we want to take ln of both sides. And we want the ln of this whole thing. And now I'm going to simplify this side a little bit. So this becomes, remember from our pre-calculus, that's ln of e to the x plus 1 times, plus ln of square root x minus ln of x squared plus 1, because this was in the denominator and these two were separated by multiplication in the numerator. And if I want to rewrite this a little more, this is x plus 1 ln of e plus 1/2 ln of, here we go, x minus ln of x squared plus 1. And we know that ln of e is just 1, so this becomes x plus 1 there. So now I want to take the derivative of both sides. So this is going to become ln, no, you're okay, 1 over y, but remember we have to multiply it by y prime. And on this side, I'm going to be left with right here. So I need to take the derivative of this. The derivative of x is just 1. The derivative of 1 is 0. Here I've got 1/2 times the derivative of ln of x, and so that's going to be 1 over 2x minus, here I have 1 over x squared plus 1 times, chain rule, the derivative of x squared plus 1 is going to be 2x. And now all I need to do is plug in for x and y and solve for y prime. However, we weren't given y, so we need to figure that out real quick. So we want f of 1 is going to be e to the 1 plus 1, square root of 1, all over 1 squared plus 1. And that is equal to e squared times 1, all over 2. So this is our y value. So 1 over that is going to give me 2 over e squared times y prime. And I have 1 plus 1/2 minus 1 over 1 squared plus 1 is 2 times 2. And on this side, I get 1 plus 1/2 is going to give me 3/2 minus 1. Okay, wait. I think I might have made an algebraic mistake somewhere. Or let me see that thing. I just have this feeling it's not going to end up. Oh, no, it is. Sorry, just kidding. This will work. Okay. E squared times y prime is equal to 3/2 minus, and this becomes 1, and 3/2 minus 1 is just equal to 1/2. So now I have y prime times 2 over e squared. So if I multiply both sides by e squared over 2, I'm going to get that y prime is equal to e squared all over 4. Sorry, this marker's not really showing up there. And that would be answer choice C. So remember, all there is to logarithmic differentiation is taking the log of both sides and then solving for y prime. And if they give you the point, then you're just going to want to plug in your x value. And sometimes you have to find your y value, as we did here. But that's just simple plug and chug. So yeah, that's how you do that.
Do you think it would be best to show this on the overhead? It's a graph.
Yeah, maybe.
All right, I'm going to show it on the overhead then. Let's see. The lights are on. Okay. All right, so we're given, I'm going to zoom in. There, that's pretty clear. And it wants us to say which of the following statements is or are true. And I'm going to grab a pencil so I can point. The first statement says the graph of the derivative of this function has discontinuities at x equals 0 and x equals 3. And we know that is true because look here, we've got a cusp here at 0, and then we've got a jump discontinuity at 3. So we can only take the derivative when the function is continuous and there's not a corner or a cusp. So that is true. So we do not have derivatives at 0 or 3, so the graph of the derivative will have discontinuities there. So we know that A is true. B says f of 2 is equal to -1. And so this is f of 2. So the slope of this graph here, it's a line, and we can figure that out by going down 1 over 1, down 1 over 1, down 1 over 1. So we know that this line from 0 to 3 has a slope of -1, so f of 2 does have the slope of -1, so B is also true. C says f prime of x is less than 0, so it means that our slope is negative on the intervals from -3 to -1, so from here to here, and then from 0 to 3. And that is true because you see from here all the way down to -1, well, from -3 to -1, we're going downwards the whole time, which means our slope is negative. And then from 0 to 3, we're also doing the same thing. We've also already established that that slope for that little line segment is -1, so we do know that it's negative. And then if we look at other intervals, here from -infinity to -3, that slope is increasing the whole time. Same from -1 to 0, that's going upward. And then from 3 on to positive infinity. Those are all positive slopes. So C is also true. And then D says f prime of 4 is less than f prime of 6. So we're going to have to do some guesstimating here because let me try and zoom in a little bit more so you can see those numbers clearly. But here on at f prime of 4 here, I'm going to try and do like a little tangent line. It's going to look like that, right? And then f prime of 6 is going to look like that. That's pretty good. And as you can see, our tangent line at 4 is much steeper than our tangent line at 6, which means that the derivative at 4 will be greater than the derivative at 6. So our part D is not correct. So, looking at the answer choices here, that C is circled incorrectly, so don't get excited. Hold on, let me zoom out. We have A and C only, well that's not true. B and D only, that's not true. A, C, and D only, that's not true because D is not included. A, B, and C, well that is correct. And A, B, C, and D, we know that D is not true. So, your answer is D.
All right, let's work. We have a word problem here, my favorites. Says the radius of a cone is increasing at a rate of 3 inches per minute. If the height of the cone is always twice the radius, at what rate is the volume of the cone increasing when the radius is 1/2 inch? Use the formula. Good, they even give us a formula. It's a great place to start. 1/3 pi r squared times h. So that's our volume for a cone and the information they gave us. So the cone is increasing at a rate. So that's going to be related to slope. That's the volume, the radius of the cone. That's going to be our DDR at 3 inches per minute. And it says that the height of the cone is always twice our radius. At what rate is the volume of the cone increasing? So dV/dr is what we're looking for. It says when the radius is 1/2 inch. So really for these related rates problems, what I like to do is always just set up my what each value is, what we're looking for, and it's really just plugging and chugging from there after we take the derivative. So I can simplify this to 1/3 times pi, and we said that h was always 2r, so it's going to be r squared times 2r. So the volume is 1/3, or I'm just going to write pi thirds actually, and this becomes times 2r to the 3rd power. So now I just want to take the derivative of both sides. So this is an implicit differentiation problem. So the derivative of v by itself is just 1, but since it's implicitly, this is dV/dr. And remember, these are all constants. This 2 pi over 3 is just a constant. So we want to use our power rule, and we're going to have to bring down our 3. So that's 3 times, and I have 2 pi thirds here, r, and then I want to decrease my exponent by 1, so that's times 2. And again, since we're doing this implicitly, I also have to take the derivative of r. So we get dr. And this becomes, so we're solving for the dV/dr. And the 3's can cancel, so I get 2 pi times, my r, it was 1/2, so I'm going to have 1/2 all squared, times ddr, which was 3 inches per minute. And so that becomes 1/2 squared is 1/4, so I'm going to get pi halves times 3. And can you see this real quick? Yeah. That's going to give me, for dV/dr, we just have 3 pi halves inches cubed per minute. And the reason that it's inches cubed here is because we had this 1/2 was an inch, and we cubed the whole thing, so I have, I squared the whole thing. So I have inches squared times the inches, which is inches cubed, and I get inches cubed over minutes, and that will just be our answer, which is A. Okay.
All right.
Actually,
No.
it's about time to
Yeah.
go.
We don't really have time to do another one, but there's only one left. But all the answers to this, as well as the free response portion that we did not get to, will be posted in the math lab, available for your viewing. You can also come and get one of these practice tests, or version B, but I think they're probably the same thing. But if you have any questions, please come visit us down in the math lab. You can find out our hours that we're open on the Teaching Center website, which is teachingcenter.ufl.edu, and I highly recommend it because it's free. Yeah, and there is a review for this test also coming up sometime next week, so check out the Teaching Center website for more information about that as well. Have a great night.